Hello and welcome to lesson 1. So these are our lesson aims. We want to recognise what a 3D printer looks like, and then we're just going to discuss why they are being used in society. And then we're going to understand how a 3D printer works and recognise the key components. So there's 4 main types of 3D printers that are out there at the moment, and they're called stereolithography, which is commonly known as SLA. You've got digital light processing, DLP, and then we've got fused deposition modelling, or also known as fused filament fabrication. And that's probably why you've signed up to this course, because you've got an FFF printer and you want to learn how to design for it. It's very rare that people have resin printers or powder printers at home. So for domestic use, for hobbyists and for education, the main type of printer is a fused deposition modelling. And it's the cheapest, it's the most accessible. It's also the easiest as well. So what does a 3D printer look like? This is the FlashForge Adventurer 3. It's one of the most popular printers in the world. It's a budget printer, it's really affordable, and it gives excellent quality prints. Now there's 4 key parts to this 3D printer. We've got the frame, we've got an extruder, we have a build platform, and then we've got an LCD screen. So we've got the printer frame here, the extruder is this bit with a nozzle on it, and then the build platform and the screen. Now every single FFF printer has those things in common. So here's a couple of other popular ones. This is called the Anycubic Mega S and the Creality Ender 3. Really popular machines, but they've all got the same things in common. They've all got a 3D printer bed, you've got the frame, you've got the extruder, and they all have LCD screens, just in a different place. So each one of these machines will give excellent outcomes. And this course, it doesn't matter what type of machine you've got. If you've got an FFF printer, everything you learn in this course is transferable to any brand of printer. So you don't have to worry about having a printer that we look at in this course. All the skills are transferable. So what do you need to get started? You need CAD, you need computer aided design. Probably why a lot of people are signed up to the course to learn Fusion 360. We're going to focus on that, and Fusion 360 is part of the Autodesk software suite. Now Fusion is free for education and free for hobbyists, and it's like a build on from Tinkercad. So if you've ever done any 3D printing or 3D modeling before, Tinkercad is like really basic. It's a starting point. Fusion 360 is really where we want to go with designing models. So you need that. We need decent computers. You need hardware. You need something. You've got to go 3D printer, obviously, and then we need consumables. So we need some filament and we need some basic tools. So filament is a plastic that we are going to feed into the 3D printer. So yeah, I would advise that you get a toolkit. Now, this is just on Amazon. Just go straight to Amazon and buy yourself a toolkit. A lot of printers do come with toolkits, but they're quite limited in what they provide, just the bare essentials. A toolkit like this is quite a good starting point, and there's various different suppliers on Amazon where you can get that. Then I would recommend adhesive for glass beds. So if you've got a printer that's got a glass bed, a 3D printing adhesive, and this is what you put down on the bed, and it helps the part stick to the bed. I recommend this brand. It's really good. It's formulated specifically for 3D printers, and it works really well. You can see the rating there is on Amazon. It's 4.5 stars, and it goes a long way. So yeah, £15, maybe that's about $18, $20, but that will last a long time, and it could be the difference between a successful print or a print failure. So highly recommend Magigoo. And then you've got to think about support. As in, where'd you go if you got a problem? Now, you'll learn a lot on this course, but it's also good to sort of be active in the 3D printing community. Now, on Reddit, there is a 3D printing subreddit. It's one of the most popular channels on Reddit, and there's all sorts of stuff that is applicable to learning about 3D printing. There's like really cool things as well, but if you need advice, this is a place to go to. And you can see there's an Ender 3 subreddit that has got over 188,000 members in it. So I highly recommend joining this subreddit. So moving on, we want to look at how to create a model to 3D print. Now this is really important. There's 3 separate components. We've got the 3D CAD, where we create the model, and then we create the STL file. That's the name of the file that we export from the CAD software. Then we need to slice the object into layers, and this is vital. When you get to this point of slicing the object, it's really important. Now there's a whole section further on in the course about slicing objects using Cura, and it's really important we get this right. If we don't get the slicing of the object right, if we don't get the slicing of the STL file correct, then we could encounter a lot of problems. So towards the end of the course, there's a big section on slicing, and you'll be really confident in preparing models for 3D printing. And then the final thing is you get your 3D printed model. So they're the 3 components that we need. We need the CAD, we need the slicing software, and then we need the 3D printer. So how does a 3D printer work? So here's a time lapse of a model that has been printed, and it's a 3D printed vase. So what we have is an extruder. This is this thing in the middle here, and that heats up plastic and it squeezes out the plastic layer by layer and then moves upward after each layer to print the model. So we'll just watch that again. So we can see layers being printed, the platform is moving backwards and forwards, and the frame is moving the extruder up after every layer. So this is speeded up quite a lot. This print actually took about 5.5 hours to print. So what do we need, right? Well, we need filament. So filament is key, and filament comes in 2 sizes. You've got 1.75 millimeters diameter, or you've got 3 millimeters diameter. Now the majority of printers use 1.75 millimeters. The Ultimaker brand uses 3 millimeters, but yeah, I'd say 90%, 95% you're going to get 1.75 millimeters. There's 2 main types that are really common in 3D printing. You've got ABS and you've got PLA. Now I'd highly recommend printing with PLA, stands for polylactic acid. It's considered a bioplastic because it doesn't contain oil. So it's technically classed as renewable because it's derived from cornstarch. ABS is an oil-based plastic. You can recycle ABS, but it's not renewable. Obviously, you can't replace oil. And also, ABS is quite challenging to print with. PLA is the easiest material to print, but when you move on to ABS, it's quite a challenge. Now, there are some times when you may need to print with ABS if you want to create a functioning part, a part that is for a specific use and you want better strength properties. ABS could be a material to use, but it is quite challenging to print with. So when you're starting out, I would recommend PLA. And there's hundreds and hundreds of suppliers of PLA. You could get it straight from your 3D printer manufacturer, or you could just go to Amazon and buy some PLA there. So once you've got your PLA, the filament will then sit somewhere in the printer. So on the FlashForge Adventurer 3, it's contained within the printer. You've got the filament, it's on the side, and then it gets pushed through a tiny little hole. There's a little mechanism there that then pushes the filament through a tube down to the extruder. Now on the other printers, the filament sits on a spool holder on the side. So the FlashForge, it's contained, there's a cover that goes on this, and then in the Creality Ender 3 and the Anycubic and many other printers like the Prusa as well, the filament is contained on the outside, and there's no real disadvantages to that. It's quite easy. If you want to change a filament, you don't have to take the case off. You can keep an eye on things a bit better. You can change the location of it. You can print your own filament holders as well. So it is quite handy to have it here. So yeah, different printers, they have different ways of loading filament into the printer. So after it's fed through the plastic tube, it then goes into this thing called an extruder. And this is a really hot chamber that's got a nozzle on it that will heat up the filament to over 200 degrees, and then it will squirt out the filament. So this is what a nozzle looks like. Essentially, you've got a stepper motor that will push the plastic through a really hot part, a heated chamber, and then the plastic will squirt out and the printer will print the layer and it will dry pretty much straight away. So different types of printers have different types of extruders. So this type of extruder in the middle you'll commonly see on a Creality Ender 3, also possibly on the Anycubic, but this one is a bit more advanced, and you'll see that type of extruder and nozzle on the Flashforge Adventurer 3, and also Ultimaker as well have their own type of nozzles. So let's just have a quick review of how an FDM or FFF 3D printer works. We have filament that is usually stored on the back or in the side of the 3D printer. It's fed through a tube into this thing called an extruder, and then the filament is heated up and it's pushed through the extruder, and then a layer is printed, and then the build platform will either move down depending on the type of printer, or the extruder will move up and it will print a layer. I always think it's really important that we quickly go over the uses of 3D printing in society and the benefits it can bring. It's quite at its experimental stage. So over the next few slides, we're going to look at examples of where it's being used, and this is one of them in the medical industry. It's being used to create 3D printed arm casts. Very few hospitals are using this, but it is becoming more and more common. So the traditional plaster cast, if you've broken your arm, it's been the same for decades. The technology hasn't changed, and now there's some hospitals that are experimenting with 3D printing casts to go on your arm. So really quite innovative. The benefits to the one on the right, the 3D printed arm cast, is you could get it wet. You could easily itch part of the skin if you've got an itch. It's quite lightweight, and also your skin can breathe. So yeah, it's quite interesting to see if this makes it mainstream. The next example is this little dog called Turbo Roo, the two-legged Chihuahua. This owner had a 3D printer and then printed their own carriage and used skateboard wheels, so the dog could get about. Previously, without access to this technology, this may not have been a positive outcome for the little dog. Turbo Roo has got a Facebook page, which you can see there's about 30,000 people that follow him. It's quite interesting actually. And the next one is James Bond, the classic Aston Martin. This was blown up in the Skyfall movie, but it wasn't a real Aston Martin. It was a mini 3D printed version. So there's only a few of these Aston Martins left in the world. They are really, really valuable, so there's no way that they would blow a real one up. So they 3D printed a mini one and blew that up in the movie. So really good use of 3D printing. Also, there's a lot of experimental work going on with 3D printed limbs. There's a lot of open source designs out there, so a lot of community groups are 3D printing these prosthetic arms for kids and for adults, and it's quite good to see communities getting involved and helping people. It's called the RoboHand, and there's a good organisation there called enablingthefuture.org if you'd like to learn more about that. Then, this is probably one of the most interesting, 3D printing with concrete. So you can print a house in 24 hours by huge concrete 3D printers. And I was lucky enough to see one of these in real life. So I live in Manchester in the UK, and there's a place called Print City, Manchester Metropolitan University, and they have a concrete 3D printer. They're funded by the EU, and they are printing with concrete and having some really interesting results there. So this type of experimental printing with different materials is taking place at the moment. Mini, they are 3D printing customizations for the inside of the cars. So when you purchase a certain type of Mini, you can actually get the dashboard customized, and what they will do is go through the different types of designs of you in the showroom, and then when your car's delivered, it's got some sort of personalized or customized interior dashboard, which is really quite interesting. And then one of the biggest 3D printed items in the world is a collaboration between Carbon 3D and Adidas, and they are 3D printing soles of trainers. So they reckon about 2 million of these a year are being printed, and it's quite interesting because you can get the sole 3D printed to the contours of your feet. So there's a lot of benefits with that. And you've got to think, would you wear some 3D printed trainers? I would. And then the final one is a map from a couple of years ago by 3D Hubs. and this showed where people had registered their 3D printers. So 3D printing is really, really global at the moment, and it's expanding rapidly. So right now there'll be a lot more markers on the map because this map's a couple of years old, but it really is growing rapidly everywhere around the world. Wherever there's computers, there's 3D printers. So, a review of the lesson. These are the things I would like you to take away from this first lesson. Can you name the key parts of a 3D printer? And can you explain the advantages of 3D printing in society today?